So as you're getting your ping pong balls, do not throw them yet. Let me explain to you what constitutes a backscatter event. So it'll be considered a backscatter event if your ping pong ball hits one of the nuclei. It's not going to be a backscatter event if your ping pong ball hits the frame or these strings or the top part. So in a few minutes, not now, we're going to ask you to stand up, and you can kind of come over more toward the center of the room if you want, and aim your ping pong ball at the lattice here. Follow the ping pong ball with your eye and discover, watching it, whether it's a backscatter, it hits one of the nuclei and bounces back towards you, or if it goes through. And also, if your ping pong ball doesn't land anywhere in the vicinity of this at all, then keep that in mind. And then at the end of the experiment, we'll ask you what happened to your ping pong ball, and you'll let us know, and we can calculate the number of backscatter events. Are there any questions before we get started? Does everyone raise your hand if you don't have a ping pong ball yet? Okay. Any questions before we get started? All right, so we'll come around and get ping pong balls to the rest of you. Those of you who have your ping pong balls can now begin the experiment.
All right, any last shots? Here we go. All right, so looks like we were a little bit successful. I saw some back bouncing. We were going to have a clicker slide on how many bounced back, but it looks like we're having a little technical difficulty with that. So what I'll ask is, can you stand up if you had your particle bounce back? All right, so let's count how many we have here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Anyone I missed? Okay, so 13 backscattered. We'll move this out of the way. TAs, if you can maybe pick up these ping pong balls for me. I'm sure it would be very amusing if I fell, but I'd rather not. All right, so we have 13 divided by 266. All right, MIT students, who has a calculator on them? Actually, I should probably do it as well so I know I'm hearing correctly. So are you getting 0.0489 or so? All right, so we've got our probability. We can go ahead and plug that in, take the square root of it, multiply it by 12.2. What are you getting for your diameters? Yep, that's what I got too. All right, so we have 2.70 for our diameter, and that's in centimeters. So we actually did a pretty good job here. It turns out that the diameter is actually 2.5 centimeters. So, good job. Experiment well done. Plus, we were not exposed to radioactivity, which is a bonus.